Hello, in this video we're going to take a look at finding a definite integral involving substitution. So we see we've got the integral from -1 to 0 of y cubed times the quantity 3y to the fourth plus 7 quantity squared, and we are integrating this with respect to y. So this is a substitution problem unless we wanted to go ahead and multiply that out. Let's go ahead and leave this one as a substitution. And so just like we've seen in previous video, we're going to let u substitute in for what's inside our function, in this case the 3y to the fourth plus 7. Now we do need to substitute in for all parts of this antiderivative, our differential, as well as those endpoints. And so our -1 and 0 are always in terms of whatever variable our differential is in. And so we need to convert those to u values. All right, so the derivative of u is 12y cubed. The derivative of 7 is 0, so we just get 12y cubed dy. We do see that we've got the y cubed and our dy, so we'll go ahead and leave that together and just move that 12 over. So we get 1/12 times du equals that y cubed times dy. All right, so we've taken care of that. We have our u is substituting for the parentheses. The only thing we have left are those endpoints. And so when y is equal to 0, what we're going to do is we're going to plug into this u equation here, our substitution equation, to find what the corresponding u value is. So if y equals 0, we will see that our u is going to be 3 times 0 to the fourth plus 7, which simplifies to just 7. And then when y is equal to -1, do the same thing, plug in y equal -1, and we get 3 times -1 to the fourth plus 7 is 10. So we are going to replace the 0 with the 7, and we're going to replace the -1 with the 10. So when we do our substitution, -1 is going to become 10, and 0 is going to become 7. Our y cubed times dy is what we're going to substitute in, 1/12 times du. And then our parentheses squared is going to be our u squared. So now we're ready to take that antiderivative, and we get 1/12 times u cubed over 3. This is evaluated from 10 to 7. All right, so if we plug in that 1/12 times 1/3, that's going to simplify to 1/36. Plugging in 7 minus 1/36, plugging in 10. And we do see that if you plug that in the calculator, the exact value is -73/4 minus 18, which is the same thing as 18.25, -18.25. All right, so the fact that this is a negative number does tell us a little bit about the graph. What we are doing when we are finding this definite integral is we are finding the area that is between our curve and the x-axis on that interval. So if we go to our y equals menu and enter our function, we do have to enter x's instead of y's here, but enter our function, and then we look at the window where our x values are going from -1 to 0, and then you can play with it a little bit. The best window, I think, is going on your y value going from -100 to 10. And if you look at the graph here, this is y equal -100 up to y equal 10, and then x equal -1 to 1. What we see is the area in between our curve and the x-axis is always below the x-axis. And so what we're seeing is that area is going to be negative because it's below the x-axis. That would be a negative area because it's below. All right, let's look at another example. Again, this one involves substitution, but it only involves substitution on one piece. So I'm actually going to break up this integral. We've got the integral from 1 to 2 of e to the 5x minus 1 over x plus 2 squared dx. I'm going to break this up into two integrals. And so I'm going to go the integral from 1 to 2 of e to the 5x dx minus the integral from 1 to 2 of 1 over x plus 2 quantity squared dx. And so we can go ahead and take our first integral, the integral of e to the 5x. Remember, that's going to be 1 over 5 times e to the 5x. We are still evaluating this from 1 to 2 minus, and then this one we're going to have to use a substitution because x plus 2 quantity squared is not just an x in there, so we're going to let u be x plus 2. So our du is equal to our dx. When x is equal to 1, our u is going to be equal to 3, just plugging into that equation. When x is equal to 2, our u value is equal to 4. So this integral becomes the integral from 3 to 4 of, that's going to be 1 over u squared, or u to the negative 2 du. And if you want to go ahead and evaluate on the first one, you can. I'm going to go ahead and wait till the end. So we get 1 over 5th e to the 5x evaluated from 1 to 2 minus the integral of u to the negative 2 is u to the negative 1 over negative 1, and that one is evaluated from 3 to 4. All right, so if we plug in a 2 there, we're going to get 1/5 times e to the 10th minus 1/5 times e to the 5th. That all is going to be our first integral. And then we're going to subtract u to the negative 1 over negative 1 is the same thing as negative 1 over u, evaluated from 3 to 4. And that negative times a negative is going to give us a positive there. Not really a whole lot of simplification as far as our exact answer we can do on this first piece. Minus a negative is going to give us a plus, and we're going to get 1 over 4 minus 1 over 3. And then we can combine like terms there. 1 over 4 minus 1 over 3 is equal to negative 1 over 12. All right, we've got one more example here. Here we have the integral from 1 to 5 of the function 12 times the quantity of natural log of x cubed all over x. So this one, if you follow the strategies for substitution, we are going to let u substitute in for that natural log of x. And the derivative of the natural log is 1 over x times dx. If x is equal to 1, u is going to be equal to the natural log of 1. The natural log of 1 is equal to 0. And then if x is equal to 5, then our u value is going to be the natural log of 5. So when we plug this in, we're going to get the integral from 0 to the natural log of 5 of this 1 over x dx is exactly our du. So that's going to be 12 times u cubed du. And the integral of 12 u cubed du is 12 times u to the 4th over 4. That is evaluated still from 0 to the natural log of 5. Notice that we don't ever go back to the x's. When we change those endpoints, we don't have to go back to x's. All right, 12 over 4 simplifies to 3 times the natural log of 5 raised to the 4th power minus 3 times 0 raised to the 4th power, which is 3 times the natural log of 5 raised to the 4th power. Or sometimes you'll see that written as the natural log to the 4th of 5. But I would probably prefer that first one. It's a little more precise. Now you can check this answer on your calculator, however you only get a decimal approximation. So if you are required to get an exact value, you are going to have to show all of this work, but you can check your answer, and I encourage my students to do so. So the way that you do it, you're going to go to your math menu and then scroll down to FN int. For me it's number 9, and then you just fill in the blanks. So our bottom endpoint is 1, our top endpoint is 5, our function there is 12 times the natural log of x, close the parentheses on that natural log, close the parentheses around the natural log, raised to the third, divide by x, so just entering your function in there, and then we are integrating with respect to x. And we see that that decimal approximation is 20.128. So if we plug in our answer, 3 times the natural log of 5 raised to the 4th, we see that we get that same answer. And so pretty confident that our work is correct there. All right, I'll see you guys next time.